We're now ready to finish this problem. So we're going to find the water horsepower and the net head. So we know things we know. We found that the tangential outlet velocity was 11.7 meters per second. We found that U2, the blade tip speed at the outlet, was 23.5 meters per second. We found that the volumetric flow rate was 0.216 meters cubed per second. We are assuming in our model that the tangential velocity at the inlet is zero. That is only a normal velocity at the inlet to the blade region. And we have this formula we derive based on momentum analysis that the water horsepower is equal to the density times the volumetric flow rate times U2T out minus U1T VT in. But VT in, we just said right above that line, was zero. So that goes away. And we can now plug in everything we need to find the water horsepower. So we have the density, which is of water, 1,000 kilograms per meter cubed. We have Q dot, 0.216 meters cubed per second. We have U2, which is 23.5 meters per second, and that multiplies VT out, 11.7 meters per second. Plug all that into our calculator. We get that the water horsepower is 59.4 kilowatts. So that's the water horsepower. That's the amount of energy that goes into our fluid as a result of this pump. We also can find the net head. We showed before the net head was the water horsepower divided by rho G Q dot. Well, now we have everything. So we go ahead and put our 59,400 joules per second divided by 1,000 kilograms per meter cubed, 9.81 meters per second squared for G, and 0.216 meters cubed per second. We crunch that into our calculator. We find that the net head for this pump is 28.0 meters. So this pump provides enough pressure to drive water up a height of 28 meters. And it delivers a volumetric flow rate of 0.216 meters cubed per second. And it creates and puts 59.4 kilowatts of energy into that water stream. So the least amount of energy that you could possibly use to drive this pump would be 59.4. But of course, that's unrealistic. Every pump will have some kind of losses. But that's the answer. So we use the geometry of the pump, the blade angles, the thickness, the rotational speed to calculate things like volumetric flow rate, power required, and head pressure, net head. All right, next time we'll just recap.